Alrighty, let's give this a try. I am trying to demonstrate the subtraction method for converting bases. So the steps that I think I need to know include knowing what the problem is and what I'm converting from and to. Then I'll write down the base that I'm converting to, and then I'll try to figure out what the highest number in that base is that I need to start with. And then I usually make a spreadsheet or a table just to try to keep things a little neat. And so anyway, so that's what I try to do. And so what I'm going to do is I am going to reference the example in the book, chapter 2, section 2.3.1. And this problem is actually about converting 104, base 10, to base 3. So if we do that, I have to know my problem, and my problem is right up here, converting 104 base 10 to base 3. And so what I do with my spreadsheet or my table is I figure out, all right, so base 3, how high up the hierarchy do I need to go to get close to 104? And so I determined that it is 3 to the 4th. And so 3 to the 4th is 81. How do I know? 3 times 3 times 3 times 3. So it's 3 times itself, 4 times 81. And then the base that I'm trying to convert from is 10, 104. And then so I do this all the way down. So 3 to 4 is 81. So this helps me determine how many digits. So now I know that with 3 to the 4th power, that's going to give me 5 digits. 1, 2, 3, 4, 5. So can't forget to include 0. So I know that my answer is going to be 5 digits. Down here, 1, 2, 3, 4, 5. Alright, so 3 to the 4th is 81. 3 to the 3rd is 27. 3 to the 2 is 9. 3 to the 1 is 3, and 3 to the 0 is 1. Alright, so I know that part. I know 104. I don't know these yet. And I don't necessarily know this yet. So 104 minus 81 is 23. And so what did I do here? This one, how many times does 81 go into 104? One time. All right. So now I got 23 as my remainder. So 23, how many times does the next 3 to the power go into it? So 3 to the 3rd is 27. 27 does not go into 23, so the answer is 0, because 23 minus 27 is a no-go. All right. So now the next level is 3 to the 2, so that's 3 times 3 is 9. So how many times does 9 go into 23? 9 times 2 is 18. So it actually goes into 23 twice. So 2 is here. So 23 minus 19 with a remainder of 5. Alright, so then 5. How many times does 3 go into 5? So 3 goes into 5 one time. So 3 to the 1. I'm sorry. How many times does 3 go into 5 at the 1 power? 3 goes into 5 one time. So I put my 1 here. So 5 minus 3 equals 2. So then I bring the 2 down here. So 3 to the 0 is 1. How many times does 1 go into 2? It goes into 2 times. 2 minus 2 equals 0. Alright, so then the answer, you start up top, you work your way down. 1, 0, 2, 1, 2. 1, 0, 2, 1, 2. Alright, so let me see if I can try to explain this to myself one more time. Alright, I know how many digits I'm going to have if I know how many times 3 will go into 104 at a certain power. And then I take that and I make my table. And so I start with 3 to the 4, 3 to the 3, 3 to the 2, 3 to the 1, 3 to the 0. This is going to be my digits. So 3 to the 4th power is 81. 3 to the 3rd is 27. 3 to the 2nd is 9. 3 to the 1 is 3. 3 to the 0 is 1. Here is my original number. So how many times, how many times does 3 to the 4th, which is 81, go into 104? How many times does 81 go into 104? Only one time. So, but it gives me 23 left over. So now the next one is 3 to the third, which is 27. How many times does 27 go into 23? 0. So 23 minus 27 is a no-go, so it's 0. All right, so how many times does 3 to the second power go into 23 instead? 3 to the second power is 9, so how many times does 9 go into 23? 2 times. 2 times 9 is 18. 2 times 9 is 18. 23 minus 18 equals 5, so 5 is left. So how many times does 3 to the 1 go into 5? It goes into 5 one time, so 5 minus 3 equals 2. So now how many times does 3 to the 0 power, which is actually the number 1, go into 2? 1 times 2 is 2. And so it evens out to 0, and your answer is 10212. Hope that helps. Thank you. Bye-bye.